Hey fifth graders, yesterday we took a look at subtracting mixed numbers with regrouping using models so we could really see what we were doing with shifting whole things over and turning them into fractions, but keeping the value exactly the same. Today what we're going to do is we're going to go forward with this without drawing models, because as we continue getting older and in more advanced math, it's really important that we can be able to solve these problems more fluently without the use of pictures. But of course, if pictures help, continue using the diagram models. But we're going to take a look without them today. So sometimes when we are subtracting mixed numbers, we need to regroup so that we can indeed subtract our fraction pieces first. So just like when we're subtracting whole numbers, such as, I don't know, 25 minus 6, we start in the ones column first, in the smallest place value. Well, similarly, we're going to start with our fractions first, our smallest place value, which would be our fractions or our parts of a whole thing. So we're going to do the same thing. We're going to start with our fractions and then work our way over. And just like this, we are going to regroup. So here we would regroup from the tens. We would borrow a set of 10, and this would become 15 ones. So we're going to use a similar method, but we're going to be using fractions. So let's take a look at an example. 3 1/4 minus 1 3/4. So if we were to start with the fractions, we would be trying to take away 3/4 from 1/4, but we cannot take 3/4 away from 1/4. So we are going to need to regroup. So again, yesterday we used models. Today we're just going to go ahead and decompose, which is break up our mixed numbers into smaller parts. So 3 1/4 is equal to 1 whole thing plus 1 whole thing plus 1 whole thing plus 1/4 of a thing. And we're already on board with that. We've seen that multiple times this unit. That is indeed equivalent to, I just really want to emphasize that we're saying that that's equal to 2 whole things. So what I'm going to do is I'm going to combine these two right here. 1 plus 1 is 2. So that is equal to 2 whole things plus, now this is going to be my 1 whole thing that I'm going to borrow from. And I'm going to borrow it in the form of a fraction, but it still is going to be equivalent to 1. So I'm going to take this 1 whole thing, which I know is equivalent to 4/4, and I'm going to bring it over as 4/4. So that I'm still adding 1. That's still equal to 1. So that's 2 plus 1, which is 3, plus 1/4. So the whole value is still 3 1/4. I'm just making it look a little different. So my last step here, I'm going to combine these fractional pieces. Okay, so I still have 2 whole things. So this is still 2 whole things. And your 4/4 plus 1 more quarter gives you a grand total of 5/4. Now you may be thinking, well, that's funky, Miss Gannon. We usually don't like improper fractions. Let's take a look at why we are really pleased with this and why we like this. So I'm going to go ahead and set this problem up now that I've decomposed it. And I've already said, so I'm just going to bring it on over here. Okay, so 3/4 is indeed equivalent to 2 plus 5/4. And from that, we will subtract 1 and 3/4. This is beneficial because I now can subtract my 5/4 from my 3/4, and I'm left with 2/4. 2 minus 1 is 1. So this would be my final answer. And of course, I would love if you could simplify 1 1/2. So this is how we can do this, solve these types of problems without having to draw pictures. Let's do another example to really make sense out of this. Let's say I have 4 3/8 and I need to take away 2 7/8. So let's break up. So the first thing I need to do, I'm recognizing I can't take 7/8 from 3/8. This is why we need to regroup, because I'm trying to take 7/8 away from 3/8. And again, looking down here, I'm trying to take 7 physical eighths away from 3 physical eighths. I don't have enough up top. So what we're going to do is we're going to use this idea of regrouping. So I'm going to kind of skip the step above. I'm going to skip separating every single one of my whole things. And I'm going to go ahead and be strategic about this. And I'm just going to pull 1 away from this. So this is going to be equal to 3 plus 1 plus 3/8. Okay, because 3 plus 1 is 4. 4 plus 3/8, I'm still at 3/8. I'm not changing the value at all. Now what I'm going to do, this is still 3 plus, I'm going to go ahead and take my 1 whole thing, and I'm going to rewrite that in the form of 8/8. Because those are equivalent. 8/8 is indeed 1, and we still have our 3/8 as well. So now I'm going to come down one more step, and this is the same thing as 3 plus 8/8 plus 3 more eighths is 11/8. This is now useful for me because now when I bring this back over here where I have everything stacked up nicely and neatly, I now can take, so this is 3 11/8, and this is still 2 7/8. I now can take 7/8 away from 11/8. I am left with 4/8. 3 minus 2 is 1, which is equivalent to 1.5. Ironically enough, same as our answer above. So we are rewriting and we are borrowing or regrouping one of the whole things in a fashion, in a form that makes our lives easier. So we're using 8/8 to our benefit, so we then can take away the 7/8 from that. Let's look at a couple more examples, and I want to show you another way that we can organize our work. So we don't have to necessarily write our fractions out in expanded form or in decomposed form. We can go ahead and start stacking it up and regrouping like we do with whole numbers. So we've got 5 1/3 and 2 2/3. So we've got 5 1/3 and we've got 2 2/3. I cannot take 2/3 away from 1/3. I do not have enough thirds. So what we are going to do is we are going to regroup, and we are going to borrow 1 from the 5, and it will become a 4. So we're borrowing 1. But when I bring the 1 over to this column, I am going to bring it over in the form of 3/3. So when I bring my 1 over and drop it into my fraction column, I'm dropping it over in the form of 3/3, because that is indeed, if we drew that picture of the big 1 surrounding this number, that is equal to 1. So all I'm doing is I'm relocating this 1 whole thing, and I now have created 1/3 plus 3/3, which is 4/3. And I'm subtracting 2/3 away from that, which I now can do. 4/3 minus 2/3 gives me a remainder of 2/3. Now I have 4 over here because I had borrowed one of those whole things. 4 minus 2 gives you 2. So your final answer would be 2 2/3. Let's do another example. 7 2/5 minus 3 4/5. So I'm going to go ahead and separate my whole numbers. I've got 7 and 3, and I'm going to separate my fractional pieces, 2/5 and 4/5. So I'm trying to take 4/5 away from 2/5. I do not have enough. I need some more fifths to be able to physically take away 4/5. So I am going to regroup. I'm going to borrow a set of 1 from here. This now will become 6. And when I borrow that 1 whole thing, I'm going to bring it over in the form of 5/5 because I'm dealing with fifths, and I needed more fifths to be able to take away the 4/5. So when I bring this 1 thing over, I'm going to drop it down as 5/5. This now gives me a total of 7/5, and I'm taking away 4 of those fifths. And I am left with 3/5 because 7 minus 4 is 3. 6 minus 3 is 3. So your final answer is 3 3/5. And let's take a look at one more example where maybe I don't give you a table to organize your work. So we've got 9 1/10 minus 4 7/10. So let's write that nice and neatly. So we have 9 1/10 minus 4 7/10. I'm going to start in that fraction column. I cannot take 7/10 from 1/10. I do not have enough tenths. So we will regroup. We're going to borrow 1 from the 9, that one whole thing, which means that now becomes an 8. Now when I bring my one whole thing over, I'm not just going to say plus 1. I'm going to bring 1 over in the form of 10/10. So I'm bringing that over in the form of 10/10. So that one thing comes over, and when I drop it into my fractions column, poof, it becomes 10/10 because that is equal to 1. And now I'm going to rewrite this. So this has now become 8 11/10 because 1/10 plus 10/10 is 11/10 minus 4 7/10. And now I can do my subtraction. I do 11 minus 7, which is 4. My denominator stays the same. 8 minus 4 is 4. And then we simplify. I can divide the top and bottom by 2. So that becomes 4 2/5. So what I want to see is I want to see how you're bringing your one whole thing over and dropping it down, and poof, it becomes the version of 1 that's helpful for us, which in this case was 10/10. So I'm bringing that one whole thing over and I'm dropping it down as 10/10.